So hello guys, good day. So it's Aziz here again. So today we're going to be having a walkthrough through a very interesting project here again. The project is about a containerized Flask applications that gives us game day schedule from the NBA. So this application utilizes Elastic Containers service from AWS, such as Elastic Container Service, Elastic Load Balancers, API gateways, and of course API, which we're going to be getting the information from. So here is an structural architecture walkthrough of the project. So here we have a user querying our application, which is making a request to request our application. So the request is going through an API gateway to our load balancer and then to our containerized Flask applications. Here are two containers. Then containers are querying through the Flask application, Flask code that is inside of them. They are querying this API, which also gets the results, the data from its own backend. So here we'll be talking about an important concept in DevOps, which is containerization or Dockerization. So containerization is actually a concept, while Dockerization is a service. Dockerization is like a service provider that enables containerization, so which is Docker. So containerization in DevOps is a process whereby you package an application with all its dependencies in one space, such that the application, whenever it is used in any system, any operating system, whether Linux, whether Mac, whether Windows, our application is going to be working very fine without dependency issues. So here we'll be utilizing AWS's Elastic Container Service. Then our load balancer. So our load balancer is like when we contain our application here, we can have 2, 3, 4 containers. We can duplicate the containers, we can replicate it as much as we have, depending on the amount of traffic or the amount of users of that application. If there are going to be a lot of users, then you can have a lot of containers. So our load balancer is, as its name is literally, that it balances the loads. It does not allow the request to go just to one container and run down container resources, but it distributes the load equally amongst the containers so that they can handle the request without downtime. So our API gateway also handles requests from the users, throttling, security, and also regulating the number of times that the user makes a request at a time, thereby preventing the DOS attacks and other things. So this is the walkthrough of the project. So let's go right into the project, into the code and the project, and let's get our hands dirty. So here we go. This is our project structure, a containerized Gameday application. So here we have our application.py, which is our actual Flask code application that is doing the whole process. Then we have our Docker file for containerization. Then we have our README set of instructions that we're going to be going through to run this project, and our requirements, the TXT file. So we have Flask and requests. So we have our .env, which is our virtual environment. When you're running any Python application, it's advisable to use a virtual environment. So it's advisable if you're working with a Python application, it's advisable to use a virtual environment because each application has its own unique dependencies and requirements. So you don't just tamper with the global settings of your Python. So let's go in and give a walkthrough of the code. So application.py. So here we have from Flask, import Flask, and JSONify. So the Flask is a Python module that is to create applications and makes requests to API web applications. Also, JSONify is to convert our Python dictionaries into JSON format. So import requests. Request is usually used whenever we are working with an API to make HTTP requests from the API. Then OS is used to get environment variables such as API keys and API endpoints. So app equals Flask name is to initialize the application, the Python application. Then here is to define the application, the API variables, API URL, and API key, which should be set as environment variables. Then at app.route/ports method get is to define our route, our endpoints, a route which is dot/ports for application. Then we define a function here which is get NFL schedule. So here we query the API using parameters, using engine, Google engine, and the query is NFL schedule, and API key is sub API key as we have said above here in our variable. So the response will also be converted into a JSON format. Then remember, we're using a try and except block here. This is a try block which tries the code and also is used to handle errors gracefully. So extract games from the sports results. So this extracts games from the sports results and returns the JSONified format and not dictionary format, and gives us a message. If there is no game, it says no NFL schedule available. Then we format the games using a loop, using a for loop, format the games into home, away, venue, the date, the time of the game. Then it saves the format into game info and returns JSONify and gives us a message that says schedule, NFL schedule fetched successfully. Then the except block to handle if there's any error in the try block above here, then this except gracefully handles it without exiting the code and it returns a message an error occurred in the JSON format. Then here is initializing the application and accessing the application through any host. Any host, anyone can access the application 0.0000 through port 8080. So that's a run through of our actual Flask code. Now let's go to our Docker file. So our Docker file is a file that we use to Dockerize an application. We want to Dockerize that application. You know, we already have our requirements here. So we need requirements is Flask and requests. So this application AppPy requires these requirements. We need to install these requirements in order to be able to run this application. So if I just send this application to somebody and the person does not have these requirements, then the person will not be able to be having some issues and errors. So Docker here now wants to package these requirements, the libraries, the application, and whatever is needed for the application to run, wants to package it in one place. So since it is a Python application, so this is from Python 3.9 Slim. So it's getting us a Python container, a Python image rather, a Python image that is going to use, that we are going to run as a container. Then set working directory inside the container to /app. Then copy the requirement file into the container. Our requirement.txt file that we have here, copy it into the container, and then we install it. Install dependencies, run pip install requirements.txt. Then we copy all the files from the requirement directly into the container. Copy the app.py, copy the request, everything, copy it into the container. Then expose the port. This is running at 8080. Remember, 8080 we expose it, then command to run the application, cmd python, then app.py, python 3 app.py or python app.py. So that is the Docker file walkthrough to be able to Dockerize the application. So we have our README here. So our README here is a set of instructions that we're going to be following step by step in order to containerize this application, store our container into the Elastic Container Service registry on AWS, use set up our clusters, set up our Elastic Load Balancer, set up our API, and then test the endpoint to see if our application is actually running. So let's dive right in. So I'll be going into my bringing up my terminal. So So we need to, if you are working on this project, so you just have to clone the application. You clone my application. It's already on GitHub. I will be sharing the link to my Git, to the repo also in the description of this video. So I'm already in the, I've seeded into the Containerized application support API. So mine is Gameday. So I've seeded into it. So what we need to do now is to first of all create elastic container registry repo where we'll be pushing our image to after dockerizing the application. So copy the so this is a command to create a repository in AWS. So AWS ECR, AWS Elastic Container Repository, create repository, then the repository name is Sports API in the region US East 1. So it's going to create a repository for us, which will confirm in our AWS dashboard. So we have repository ARN ID, repository name Sports API. So let's confirm that in our in a Jiffy. Okay, this is our container service. So I think it's supposed to be a public repository. Private repo. Yeah. So here we are. Our Sports API has been created. So that is that. So when we dockerize our application, we're going to be pushing it into this repository. If you check this repository now, to tell you there's no images displayed. So after we docker the application, we'll be pushing the image right into this place. So we have to log into the ECR. So using this command. So AWS ECR. So the command says AWS ECR get login password. AWS ECR get login password region US East 1. So getting this login password and you piping it. This is a pipe. The login password, you pipe it into this command. Docker login, username AWS, then password are standard inputs that we have piped into here for this account. So we're going to be copy my account ID with the same one from your end also. Copy my account ID and put it into here. So my account ID, here's my account and ID is copy. Okay, the command docker could not be found. Okay, this is happening because I have not started my Docker. I'm using Docker desktop, so I have not started my Docker engine. So you might also get this error. So you have to start your Docker engine using Docker desktop. So let me go and start my Docker engine so that we can continue. So my Docker engine is up and running now. So I will run the command. Okay, so login succeeded. I'm logged into the ECR. So the next thing is to build our image. So Docker build platform Linux, then our Sports API. So it's building this application now using this Docker file that we have described earlier. So it's building this application.py, building it to an image. So the process of Dockerization. Okay, so our application is Dockerized. Dockerization is complete now. So the next step is to tag the image and then push the image to the ECR repository we created earlier. So here we tag the image. So one of the reasons that we tag is that we tag in order to know the different, so that we can tag, we can track the different versions, the different build versions of an image, and also most importantly to prepare the image for ECR push. Because if we do, when we build this application now, we're having name like sports API. Okay, let's name like sports API. Let's check the Docker images. So we have sports API. So 3 minutes ago we have sports API. These are the repository name, then tags latest. So we need to tag it with the URL of the ECR repository before we push it. If we don't do that, tag with this here. This is the full repository name push. Okay, here is the tag here. From my account ID here up to the full URL of the ECR repository, then the image will not be recognized by ECR when we try to push it. So that is why we need to tag the image before pushing. So I have to copy this. So also remember to change the ID to your account ID, to AWS account ID. Copy. So image is tagged. The next thing now is to push the image. Have to push the image. So same thing, change the ID. And we'll push our image to our ECR repository. So image is pushing. So our image is pushed to the ECR. So let's confirm that. Okay, here we are. So let's load it. Yes, so our sports API latest. So here is our image. So our image is pushed. So the next thing to be done now is the deployment process. So we are going to be using Elastic Container Service. We're going to be using ECS Fargate, which is a managed service, serverless managed service for us, creating a cluster, creating task definition services, and deploying it on ECS Fargate, and then linking it to our load balancer and our API gateway. So let's dive right into that. So what we need to do now is to create our ECS cluster. So we'll go right into our AWS control to our ECS, then we'll create our cluster, we'll name it Sports API cluster. So let's dive right into that. So it's our ECS service, so clusters. So we need to create a cluster. So we have a Sports API cluster. So infrastructure. So we're choosing Fargate here because the serverless, as you go, it's managed. Then leave all of that in that optional. Then we create. So it's creating our cluster for us. The cluster in progress. So our cluster has been created successfully. So we have our Sports API cluster. So the next thing is to create a task definition. So what is a task definition in ECS? It is the It's like a blueprint for how a container or group of containers should be run in terms of their configurations, um, the IAM roles, the security, and the configurations of the of the containers. So basically, it is the recipe for running containerized application in AWS ECS. So here now we're going to be creating a new task definition. So create new task definition. So we're going to be calling our sports API task. So let's see sports API task. Oh, let's just say Aziz to make it unique. So as usual, I'll be using AWS Fargate. Yes, task size, CPU, memory. So task row. So we're going to be having, so for task row, we can leave all these, then move to our containers. So we're going to be adding our container. So let's name our container as Aziz Sports API container. So our image URI. So we're going to go and copy our image from the ECR, Elastic Container Repository Registry rather. So this is our image here. So the URI of the image is here. So copy URI. So image URI copied. So we're going to input it into the task definition here. So image URI essential container, yes. So our container port is 8080. So TCP, port name optional. So port name can leave it. Our protocol is HTTP. Then CPU memory one. Yes, environment variable. So our environment variable that I have here is firstly our sports key, sports API key, and then so I have to add my sports API key here, value. So let me get my API key. Do I have it here? Yes. So I'm going to be adding my, so that's my API keys. So scroll down, I think it's okay for now. So we can just create our task definition. Task definition created successfully. So next thing is now to create a service. So here's our container. Here is the image URI the other time. So now we need to create a service for our container. So here is what we have. So what we need to do now is to create a service. So go into our cluster and click into our cluster and services and create service. So what is a service? So basically a service is used to, it's also used to run a container just like a task, but it has more functions and capabilities than a task because it enables auto scaling, availabilities, and run multiple tasks and make sure that all the tasks and containers are always up and running. So let's get our tasks. So we can also define load balancing also using services. So let's start that. Okay, Sport API cluster is existing cluster. So as in capacity provide service, Fargate, latest. So using services and not a task. So service. a group of handling long-running computing works that can be stopped and restarted. So it helps us handle ALB, load balancing, auto scaling, and the likes. So the family has this ports API task. So the task we used earlier. So the vision is supposed to be about the latest. Okay, task name. So a service name as a port API service. We're using replica tests, desired tasks. So this task here is like the number of containers that we want. So let's use, we'll be using 2. So like it is in our, we have in our architectural diagram here, container 1, container 2. So our containers in the ECS service are 2 containers. So we're using 2 containers for this purpose. Deployment, service connect, networking. So we'll be creating some networking here. So we're using our default VPC, and we have 6 availability zones. I think for service to work well, I think it requires a minimum of 4 subnets, but here we have 6, which is okay. Security group, creating a new security group. Yes, we're using all TCP. So from anywhere, for this project we're going to be using anywhere. So for this project we'll be using anywhere, just for this project, because normally you should not be using anywhere because of security purposes and the likes. So here we'll be defining our load balancing. So we use load balancing, application load balancer. Our container is already here. Let's create a new load balance. As this port API ALB, health check period, listener, port 80, HTTP. So our health check part is /port. Yeah, /ports. If you check our code, we defined in the app.py, /port is our endpoint that we defined here. So we'll be using /ports also in that instance, /ports. Then we can create our service. In progress. This might take some minutes, so let's hold up. So our service has successfully been created. So nothing you need to know is to test our ALB endpoint. So here our service is active, 2 tasks running, deployment completed. So it has been deployed successfully. So if you go to our ALB, I have load balancer. Let's load. So we'll check through the load balancer DNS to see if our application is actually running. So our load balancer is here. Our load balancer is active, 6 availability zones. So let's take the load balancer's DNS. So here's the DNS. Copy. And let's go to our browser and let's add /ports endpoint behind. You can see what we have. Yes, we have something. Our endpoint ALB DNS is working, so pretty print. So we have games. So here we have no NFL schedule available, but the point is our application is currently working. Yeah, currently working. So probably there are no games at the moment, but our code and application is currently running. So the next thing to do is to set up our API gateway. So let's dive into that API gateway. So to create the API gateway, so we'll be creating a REST API. So building the API. So I won't be diving into this from here. So I'm going to leave that to you to take it from the readme here, configuring the API gateway. So this is the instructions. It's pretty straightforward, so you can dive into that and get it done. I won't want this video to extend more than this, or going into a part 2. So here we've learned how to set up a scalable containerized application with a